This is sps1a Unit 1 exam remediation. You have a sheet that goes along with this. Please make sure to fill in this sheet as we go along in the video. If you need to pause the video or rewind, make sure that you do so because you'll be turning in this paper to your teacher. So the first thing we have is the structure of the atom. So when we're looking at these things out here in the outermost energy levels, those are going to be electrons. They have a negative charge and they exist in those outer energy levels. Inside the nucleus here, we have these things that have no charge, which are the neutrons. Also inside the nucleus, you have the protons, okay? And those are positively charged. So if we're looking at the periodic table, you have a box for each element. At the top of the periodic table is the atomic number. In the case for boron, that's going to be the number 5. Okay, so what does the atomic number tell us? In a neutral atom, which means that it has no charge, then the atomic number is going to tell us how many protons and electrons. Okay, so the thing that you have to know is that protons are never going to change. If protons change, it will change the name of the element. Like, for example, if boron suddenly had 6 protons, it would no longer be boron, it would be carbon. Okay, so if you look at your periodic table, the thing that has the atomic number of 6 would be carbon. The bottom number, in this case for boron, which is 10.81, which we round to 11, is the atomic mass. And the atomic mass is made up of the nucleus of the atom, which has our protons and our neutrons in there. So always the atomic mass tells us how many protons and neutrons. Our atomic number always tells us the number of protons. Now, in another video, if you have to do that remediation, we'll be talking about ions and some in this video as well. In ions, your electrons sometimes change, but protons never ever change. Also, electrons basically have no mass. So if we're talking about the mass of the atom, we're only talking about protons and neutrons. Electrons are so light that they're not considered in the mass of the atom. So if we wanted to make a model of potassium, for example, and I gave you a bunch of baseballs, marbles, and tennis balls, what would represent each? Well, think about the size of baseballs, marbles, and tennis balls, and think about which ones are the heaviest and which one is not. We know that marbles are not so heavy, right? So which one would have to represent marbles? Baseballs and tennis balls are pretty close to the same mass. So which two would be ones that would be baseballs and tennis balls? Well, the ones that have the mass of the atom are going to be protons and neutrons. And because those have about the same mass, we would use tennis balls and baseballs for them. So what would be marbles? Well, your marbles would be electrons because the electrons, we say, basically has no mass in the atom. So we would use those marbles for that. So if we're looking at potassium here, how many protons and electrons would I have? Well, we would have, remember, the top number up here always tells us how many protons and electrons we have in a neutral atom. So in this case, we would have 19 protons and 19 electrons. And then to get neutrons, we take the bottom number, which is 39, minus the top number, which would be 39 minus 19, which would be 20. So for protons, then you would have 19 tennis balls. I would have 19 marbles because that would be my electrons and 20 baseballs. So remembering that to calculate protons and electrons, our atomic number is going to be the same as protons and electrons in a neutral atom. Your neutrons, we take this bottom atomic mass and subtract the atomic number. All right, so looking at this, if we wanted to, I have to click on here. So what if we want, what can we tell about the atomic mass by looking at the chart? Well, It's something that we probably already know from previous discussion, even in this video. But if I look at my atomic mass here is 39. What in here is giving me 39? Well, I know from the previous slide that electrons have no mass. But if I take my protons and my neutrons and I add those together, 20 plus 19 gives me 39. 18 plus 22 gives me 40. 7 plus 7 gives me 14. Now, we have to remember that the electrons are not included in the mass. We consider those to have no mass at all, okay? So the thing we can tell by looking at the chart is that the atomic mass is equal to the protons plus the neutrons. So when we determine the charge of an ion, and remember an ion is an atom that has become positively charged, which would be a cation, or negatively charged, which would be an anion, okay? So when we determine the charge of an ion, we have to remember the charge of the subatomic particle. So remember, protons have a positive charge, electrons are negative. And the easiest way to figure out what the charge of the ion would be is to do protons minus electrons, okay? It always works. So if we look here, this one has 3 protons and 2 electrons. If I do 3 minus 2, that's going to give me a positive 1, okay? So, okay, there it goes. Okay, so 3 minus 2 gives me a positive 1 charge. Okay, so let's look at argon. Remember, we're going to do protons minus electrons. So if I take my protons minus my electrons, 18 minus 18 would give me 0, which is what we consider to be neutral. You could say 0 charge, but know that that means neutral. That means it's not positive, it's not negative, okay? So look at nitrogen. If we take our protons minus electrons, 7 minus 10 is going to give us negative 3. So this one has a negative charge. Okay, so if we want to build a model of an ion, we've got to know how many protons, electrons we have before and after bonding. And we really need to look at the elements. So for lithium, find it on the periodic table. It is number 3. And so if we look at lithium, how many valence electrons does it have? Well, it has 1. Okay, so is it going to give 1 away or take 7? Well, we know if an atom has 1, 2, or 3 valence electrons, it's always going to give those away. So this one is going to give away 1, okay? And it only has 1 to give that's in the valence, okay? So what charge would that be in bonding? Well, if I lose an electron, I give away one of my negatives, I'm going to become a positive 1, okay? So let's look at how many protons and electrons we have before bonding. Look at lithium on the periodic table. Its atomic number is 3, and we know that protons and electrons for lithium before bonding is going to be 3 and 3, okay? After bonding, we know that protons are going to stay the same because protons never ever change or the element changes. But if we're losing 1 electron, then instead of having 3 electrons, I'm going to have 2 electrons, okay? So if we're looking at this, then I can go over here and I can draw, get this, popping up the wrong thing. I can go over here and draw this one. Okay, so I'm going to take, I know that I have protons and electrons, and we actually need to figure out our neutrons too. So I know in this atom that I have 3 protons, I have 2 electrons because I gave 1 away, and my neutrons, if I look at lithium, there's a 3 for atomic number, and then we have 6.9 something, so we round that to 7. So my neutrons would be 7 minus 3, which gives me 4, okay? So to draw this, I would do 3 protons, which I'm going to put in here, okay? I would do 4 neutrons, which I'm going to put in here. Now I have 2 electrons to place, okay? And so these 2 electrons, how many can fit on the first level? Well, 2. And so this would be what it looks like. So in a model that I build for a +1 ion of lithium, which would be written like this, lithium +1 or 1+, then I would have 2 electrons, 3 protons, and 4 neutrons.